Hello, my name is Paul Bevan from Siemens Digital Industries Software, and in this demonstration I'd like to take you through a brand new validation tool in the December 2023 release of NX called NX Corrosion Analysis Indicator. It looks at providing corrosion analysis of component parts in an assembly based upon their proximity and also the assigned materials and coatings, and it predicts the corrosion risk rate based on the galvanic properties of these assigned materials using the latest industry approved methods. So let's take a look at it in more detail. So in the graphics window you can see that I have a small assembly of an aircraft structure made up of some clips, some ribs and some spars, and I want to perform a corrosion analysis on this assembly. Now, the components themselves have had some materials assigned to them. So if we take a look at the properties of that one spar, you can see it's made up of an aluminium material. Similarly, if we take a look at one of the ribs, then again they have a material assigned to it. So we've got the information that we need associated with the component parts. So now we can go ahead and perform an analysis. Corrosion risk analysis can be found under the HD 3D tools. I double click it to enter the dialog, and you'll notice that I have two environments I can choose from. One that is commonly used, the other is more for a military standard. For my case, I'm going to use the commonly used one. I then select the components within my assembly, and then I get a list of results showing me components that are attached to each other. I can now calculate my corrosion risk assessment based upon upper and lower limits. I'm then presented with a set of color-coded results based on the galvanic corrosion rate, whether that's low, medium or high. Will give me a green, yellow or red color coding. Now that I've expanded the corrosion risks results window, you can see some of the other important information that we can find in the various columns. So we can see which are the anodes, which are the cathodes, the galvanic corrosion rate itself can be seen, and also if we were interested in the military standard, then that's something else that can be seen within the results window. I can also highlight the body pairs that are specific to a particular risk. Here I've selected rib 4 and the aft spar, which has a high corrosion risk. It's also possible to filter the results level. So in this case, I just want to see the face pairs, which gives me a far more granular look at exactly what's going on. It's also very easy to configure the results. Here I'm simply switching off the military standard. I don't want that. I can also reorder the columns themselves so that they are presented to me in the form that I want. In addition to that, I can do a sort on any of the columns that are presented to me. So let's take a look at the high risk result in a bit more detail. If I use mouse button 3 over the result, I can study the interference and take a look at it. You can see highlighted in red the faces that are touching between the spar and the rib. It's also possible to generate a report giving me more information. Here you can see both the materials of the components and the galvanic corrosion rate itself. And I could go ahead and print this information off. Now that I've studied the results in more detail, I can go back in and restore the component visibility to its original state. If we take a look at some of the other information here, you can see that rib 2 and spar aft has a low corrosion risk. But rib 4, which is attached to the same aft spar, has a high risk. And that's because rib 4 is made out of a different material to the rest of the ribs. Now this may be as designed, but I think there's a fair chance that the material has been input in error. So let's go ahead and make a change. So I'm going to make the rib 4 my work part within the assembly.
I'm going to access my materials library. I'll find the material I want. I select it. I then choose the rib and apply that material to it. You'll notice in the Assembly Navigator the material has changed. I go back to the corrosion risk analysis results. You can see that they're now out of date due to the fact that we changed the material. All I need to do now is to recalculate the risk analysis. And you can immediately see now that the rib 4 and the aft spar are a low risk of corrosion. Now I'm sure you will have already noticed that there was a fourth colour with respect to corrosion risk, and this is an unknown risk. And the reason why it's unknown is because rib 5 has no material assigned to it, so we couldn't do the calculation. So again, if I wanted to, I could go back in, add a material to rib 5, and again recalculate the corrosion risk. In this final part of the demonstration, I'm going to see if I can achieve a positive effect on the medium risk items that you can see in the results. You'll notice that the spars are anodes and the clips are the cathode. And that means that our more expensive and more difficult to replace spar is going to corrode faster than the cheaper and easier to replace clip. So let's see if we can effect a change to the clip that will improve our corrosion risk analysis. So rather than changing the whole material of the clip, all I'm going to do is to add a coating to it. So I go into the coating application, I specify a coating region, and then I add a coating layer to that clip. It changes color, as you can see, to signify the fact that we've added a coating to it, and you can see that within the coating navigator. So I'm just going to go back to the main assembly. Again, you'll notice the clips in black, the ones that we've just added our coating to. I re-access my analysis results, and I'm going to recalculate. And now when I get the results, you'll notice that even though the clip and the ribs still have a medium risk, it's now the clips that are going to be the ones that corrode as opposed to the ribs. So let's just recap what you've seen. We've taken a look at a brand new check-in function inside the December 2023 release of NX called NX Corrosion Risk Analysis. It easily determines the components that are in contact with another and where corrosion is most likely. It makes use of standard defined materials, and it evaluates the impact of any assigned coatings. You can choose the environmental condition to evaluate within, whether a more commonly used one or a military standard, and it provides results in color-coded graphic feedback for easy visualization. And it also offers detailed information to help educate users. I'd like to thank you for your time and attention.